Hi everyone, Radko Tutor here explaining. In this video, we are going to look at how to prove this question. This question is coming from complex variables, which is also called complex of several variables. It is a fourth year course. Mostly it is taught at fourth year course, mathematics at degree level. So what we are going to do is, we are going to prove this from here, taking it to there. So how can we prove that this is equal to this? So to prove that this is equal to this, you've seen that here we have a 1 minus z to the power n plus 1. And then down here we have 1 minus z. So what we are going to do is, we are going to start by making some assumptions. So the assumption that we are going to make are that the first one, we are going to say, let s to be equal to 1 plus z squared plus dash 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 plus z to the power n. So what I've done is that I've just let z to be what is given here from the right hand side, from the left hand side. Okay, so from here now, after making this assumption, what we are going to do is, we are also going to make an assumption that let us also have s minus zs. So why am I creating this assumption? I'm creating this assumption because of the minus that I've seen there, and also because of the n plus 1 that I've seen on top on what we are proving. Because if we have something n plus 1, meaning that there should be something multiplying for you to add the powers. So no wonder I've created s minus s times s, or s minus z times s. That's what we are going to do. So from here then, we are going to replace what we have in the question. So to replace what we have in the question, we are going to say we have our s minus zs. Our s minus zs is equal to, we are now going to replace. Where there is s, we are putting this assumption here that we've created. So where there is s, we are putting that, which is a 1 plus z to the power 2 plus dash 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 plus z to the power n. Okay, minus, there is a minus here, so there is this minus here, minus z, so you write minus z, so we have minus z, open, because z is multiplying with s, so we're going to open the brackets, and then we put again our s. So our s is where? Our s is this one here. So we replace our s, which is 1 plus z squared plus dash 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 plus z to the power n. So that's what we are going to write. So we have, we are going to have 1 plus z squared plus dash 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 plus z to the power n. That's what we have. And then from here, we are going to multiply the z. We are going to multiply this z throughout what is inside there. Okay, so let's do that. We see. So if we are to do that, we are going to have s minus zs is equal to, we have 1 plus z squared plus dash 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 plus z to the power n, minus, we now multiply the negative z times 1, we get negative z, and then we have negative z times positive z, we get minus z squared, and then we have negative z times positive z squared, we get minus z to the power 3, and then plus dash 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 dash, we also multiply negative z times z to the power n, we get, if we multiply z to the times z to the power n, remember when we are multiplying variables of the same base, you just need to add the powers. So in this case, we are multiplying the z times z to the power n, meaning that we are going to maintain the power of z here is 1, the power of z there is n. So we are going to have z to the power n plus 1. So we are going to say plus, here we say plus z to the power n plus 1, because we are adding the powers. The power here is 1, the power there is n, so we add those powers. Okay, then from there now we are going to check if we have like terms so that we can subtract them. So do we have like terms? Yes, we have, because here we have s minus zs is equal to, we have the 1, we don't have any number which is liking to 1, so we have 1. The z and the z here, they will go, because this is positive z, that is negative z, so those will cancel out. And then from there we are going to also have z squared, and the z squared also will go. Also, what is going to go? The z to the power 3 and z to the power 3 also will go. Why are we cancelling? We don't have z to the power 3 here, but we've seen we have dashes here to show that these powers are still going, meaning that this is z to the power 1, z to the power 2, z to the power 3, because we have those dashes like that, up to z to the power n. So no wonder I've cancelled the z to the power 3 and the z to the power 3, which is unseen here, but I've cancelled it because we know that the meaning of those dashes, meaning that we also have z to the power 3 and z to the power 4, z to the power 5, and so on and so forth. Alright, so now from there, after cancelling those, we need to write what we have. So what we are remaining with here is just minus z to the power n plus 1. Okay, so we say minus z to the power n plus 1 like that. Okay, that's what we are remaining with, which is this one at the far end here. That's what we are remaining with. Alright, where is, remember all the terms here after multiplying the z to this, they are having a negative. So that's the reason why you've seen I've put this minus here, because all the terms are being affected by the negative after you multiply. Okay, so in other words, if you want, you can even put here, you put a minus so that you can not get confused. So minus z to the power n plus 1. Okay, now from here, remember we want to prove that this is equal to that. So that's what we are reducing. So now how can we reduce to that? You are going to say that here we have s minus z times s, and you've seen that z is common here. So what can we do? We can factor out the z, the s which is common. So factoring out the s which is common, we are going to say s is common, we remain with 1 minus z, and is equal to 1 minus z to the power n plus 1. That's what we have. Now what can you do for you to remain with s? You are going to remain with s by dividing here by 1 minus z. You also divide by 1 minus z, meaning that this and that will go, and therefore our s will be equal to 1 minus z to the power n plus 1 over 1 minus z. And this means that we've proved this identity, that this is equal to that. Remember, you've seen this, what was given to be proved is what we found here, and therefore you say hence proved. So you just say hence proved. Alright, so you say hence proved. Hence proved, like that. Alright, now I'm going to give you some work that you're supposed to do, but please, the work is on my YouTube channel. So go and subscribe to my YouTube channel. That's where I have a lot of videos on complex variables, well explained. Kindly don't forget to also follow my Facebook page, because this is where I'll be sharing more of the videos as well. See you next time.